Hey everyone, it's John again, and today I'm going to continue on the BGP video series. So in this video what I intend to do is just do a little demonstration on BGP peering, that is peering with authentication, changing the timers and using peer groups. The actual peering will be done in this case on the left hand side with iBGP and AS5 and between autonomous systems, so eBGP between 5 and 13, 13 and 24 and 13 and 79. Now what I will say is iBGP does require a little bit more detail, and I'll be doing an examination of that in a separate video dedicated just to iBGP, but for the purpose of this video we're just going to continue on and include iBGP anyway. So like I say, the basic topology is we've got on the left hand side AS5 and we've got a directly connected neighbor between, not neighbor, but directly connected interfaces between R1, 2, 3, 4, 5, 6. They all kind of link to each other, and each router I've configured with a loopback of its router number. So effectively 1 has got a loopback of 1.1.1.1, 2 has got a loopback of 2.2.2.2, 3 is 3.3.3.3, you get the idea. So what I will say is that in the case of iBGP, which we've got on the left hand side, iBGP, it is very common to peer via loopback addresses, and for iBGP to actually run on top of an IGP. So despite that kind of sad letters, what that means is you want to be running iBGP in tandem with your OSPF or your ISIS or your EIGRP, so on and so forth. And that's what we'll do quickly just now. So the first thing I'll do is I'll put an IGP on this to give us reachability between the loopbacks, because if I try to peer between loopbacks of 1 to 2 here, this has got a directly connected network, so it knows about the 205.0.0.2 in this case, and this one knows about 205.0.0.1, the interfaces, but they don't know about the loopbacks. We need to actually have an IGP or configure static routing to provide reachability between the loopbacks. So what I'm going to do is just put this IGP on, and then from that point of view we'll do a little bit of BGP peering and we'll move on. So let's go and do that just now. So in the case of router 1, I'll just show you. We've got show IP int brief, and you can see the basic thing. We've got our address here and our loopback. So what I'll do is I'll just put an IGP, you know, I'll put an ISIS just to be different now. Make it a level 1-2 type and just put the net. Don't worry too much about this if you're not used to ISIS. I'm just going to just quickly put this on and do int. And I will say all the loopbacks are loopback 0. So that's that one. Enable conft router ISIS. Oh. And pop that in here. Enable configure terminal router IS type, then a level 1-2 and net 49. Oh. And int gig 01 IP router IS and int loop 0 IP router IS. Give that a little second. Just check we have reachability. Okay, so now we can see we have our loopbacks which we've learned via ISIS. So if we can just ping the 3 and we can ping the 2. Oh. So now within this AS, we can ping all loopbacks, we'll get full reachability. So what we're going to do here is configure iBGP and do so by peering via the loopbacks, because we now have reachability between loopbacks. So let's go and do that then. So we'll do conft router BGP 5. Okay, so the first thing when you're configuring BGP, you need to specify what your the neighbour's remote AS is. Now that's called the remote AS, you might think that means it's going to be a different AS. Now for iBGP, the remote AS just happens to be your AS. So we are in router BGP 5, so the remote AS is actually just going to be 5. So we'll do neighbour 2.2.2, which is this router here, and remote AS is just going to be our AS. Now the router knows that it's going to be using iBGP, and the rules of iBGP will follow. So the next thing we're going to do is do neighbour 2.2.2, and we'll do the update source. Our update source, because we're peering with our loopback, which is going to be 1.1.1.1 and not this interface of 205.0.0.1, we're going to say the neighbour, letting that neighbour know our update source is going to be our loopback address of loopback 0. So the next thing we're going to do is change the timers to keep it a little bit more efficient, and we'll do what we'll do hello of 10 and hold time of 30. And the last thing we're going to do is put a password on, and you'll notice once I put the password on here, we're going to get all these error messages coming out because it's not receiving the password back from router 2. So you see that there, no MD5 digest, so that's just going to keep spitting that out. Now another thing you need to know is with iBGP, there is, again, effectively iBGP has to be configured in a full mesh, so we actually need to peer with router 3 as well, even though they're not directly connected. That's a common thing with iBGP. Lots of the peers are just not directly connected, they're actually connected through the IGP, which it's riding on top of. So we're going to peer with that, and again I'll explain why that has to be done in my actual iBGP video. So we'll do neighbour 3.3, and we'll do remote, we'll do neighbour 3.3, update source is going to be loopback 0, neighbour 3.3, and our timers are going to be 10 and 30, and neighbour 3.3.3, and our password is going to be Cisco. So that's that done, and we'll do the same here on router 2. Now you can see what I'm doing, it's not the most efficient way to be doing this. So if I do neighbour and do remote, there's a lot of commonalities with what I'm typing here. I'm always typing timers 10 and 30 and neighbour up update source and password Cisco. So we'll do now number 3, and when it comes to number 3 I'm going to use a peer group, which you're going to see it's going to be a bit more efficient than doing all this. So we'll do a neighbour 3.3.3, and we'll do our update source as a loopback neighbour 3.3.3. Oh. And we'll take our timers to 10 and 30 and neighbour 3.3.3, and our password is Cisco. Okay, so what I'm going to do is, actually just check that's come up on that. Yeah, that's come up there, that's fine. So if you notice, like I said, show run section BGP, we have these commonalities like update source being typed, password being typed, timers were the same. In the case of this router, I'm going to do the same configurations but use a peer group. And you'll see how that makes things easier. The difference is going to be marginal because it's a small network, but when you're dealing with say 50 devices, 10 devices, whatever, it's so much more efficient doing it this way. So if I do router BGP and I do a neighbour and call it what we call the peer group, we'll call it John, and just say peer group. So that's how specified that. So now we can just put all of the commonalities under the John peer group and then specify the actual neighbours afterwards. That might sound a little bit abstract, but if you just follow me, and I'll just configure and you'll see what I mean. So I'll do neighbour John remote 5 neighbour. These are all the things which are common. So the timers neighbor of John timers 10:30, neighbor John update source is loopback 0, neighbor John, and we'll do the password of Cisco. Okay, so now we've actually, all these things which we'd have to do for 1.1.1 and 2.2.2, we can just do it all in one. We don't need to type update source multiple times or timers multiple times. Just do that once as the template, and then we can just do neighbor and specify the neighbor. So neighbor 1.1.1 and just say peer group John. That lets it know the 1.1's part of that peer group. And the same with this one here, neighbor 2.2.2 peer group John. And that's all you need to do for that one, because the peer group specifies the commonalities. So if I just do a show run section BGP, that's just come up there. You see, we only need to type update source once, timers once, so if we had, say, lots of neighbors, we could just keep typing neighbor, and that neighbor is going to have the same settings as this peer group John, and the peer group John has this setting, this setting, this setting, and it's in remote AS5, so that makes it a little bit easier. So that's how you use peer groups. The next thing we're going to do is with router 3, we are going to peer with AS13, and we're going to use a different password this time just to show you that you don't need to have common passwords throughout everything. So we'll do router BGP 5 and just peer on the actual physical interface this time rather than the loopback. So we'll do 13.0.0.2, which will be this interface here. So neighbor 13.0.0.2, and the remote AS is going to be 13, because this number here is different from this number here. BGP can interpret this as two separate autonomous systems, so now we're using eBGP, which is going to have different rules than iBGP. So that's all the difference is between configuring iBGP and eBGP, is these numbers will be different when it's eBGP and the same when it's iBGP, and subsequently the protocol will behave differently depending on which one you've got configured. So we'll do neighbor 13.0.0.2. We don't need to do an update source because we're using a physical interface this time, and we'll do timers, just do 10:30 again, and neighbor 0.0.2, and we'll change the password to John with capital letters rather than Cisco. Now you'll see that we'll probably start getting that message of the MD5 spitting out because it's waiting on the next router to authenticate. So whilst that does that, we'll go over here and we'll do enable conft router BGP 13 neighbor, and again we're peering on the physical interface and it's remote 5 this time, so we're peering with that one. We'll do neighbor 13.0.0.1 and we'll change the timers to 10 and 30, neighbor 13.0.0.1, and the password was capital John, I think. Is that right? Oh, just check that's right there. Just give that a little, there we go, just taking its time to come up. That's the thing is with BGP, it doesn't come up like eIGRP, it can take a little bit of time and you think you've made a mistake with the configuration, so just be wary of that. Okay, now with the case of this router here, what I'll do is, what am I doing? What I'll do is, I think I'll do loopback in that one. Try to think what would be best for the demonstration. We'll just do physical on this one as well. So we'll do router BGP back into 13 again. We're still on this AS, and the neighbor here is going to be 24. In fact, you know what? No, I'll do it in the loopback as well. So no, do you know what? keep it straightforward. I'll save the loopback for the last one. 24.0.0.2 and remote 24, neighbor 24.0.0.2, and we'll do a timer of 10:20, neighbor 24.0.0.2, and just put the password back to Cisco again. Okay, and we'll do Okay. Router BGP, neighbor 24001, remote 13, neighbor 24001, and we'll do timers 10 and 30, neighbor 24001, and the password is going to be Cisco. Give that a little second to come up. What you can also do is you can actually put descriptions on the neighbor. This is quite common because BGP is so scalable. It's good practice to keep your head straight, because you might have lots and lots of neighbors here. So we just do neighbor 24001 and type description, and you can write a wee description in here, so that it can just say connecting to AS13. So we do our show run section BGP. You can just eyeball this and know, oh, this one is connecting to AS13. So that's configuring an eBGP between these two. And the last one I'm going to do is do eBGP but peering on the loopbacks. This happens as well quite often because you want to have multiple connections between redundant connections between routers, and it's just often quite a good idea to use loopbacks, to be honest. So let's go and do this. And we shall do router BGP 13, and the neighbor is going to be all the 6s because it's loopback 0 of 6.6.6.6. So we'll do neighbor 6.6.6, and remote AS is going to be 79. So we'll do 79 neighbor 6.6.6. Timers 10, 30, neighbor 6.6.6. Update source is going to be our loopback, so we're going to be appearing from 4.4.4.4 in our one, and we'll do neighbor 6.6.6, and we shall do a password of Cisco. Okay, and we'll go across to here. And do router BGP 79, and we'll do a neighbor of all the 4s, remote 13, neighbor all the 4s, update source is our loopback, which is going to be all the 6s, timers 10, 30, neighbor, password is going to be Cisco. Now you'll notice that we're not going to get a peering coming up. So the first thing which you might think is we don't have a route to get to 6.6.6 from number 4, and from 79, which is 6.6.6, back up to 4. So let's configure a static route and see if that makes a difference. There might be something else wrong though, even though this will have to be configured anyway. So we'll do an IP route going to, and our exit interface is going to be gig02, so we'll do that. Okay, so let's go back to router 6 and do the reverse of that. We'll do an IP route of all the 4s, and again gig02 is the exit interface. So if we do a show IP route, we're going to have a static route to all the 4s, ping. Okay, now we can ping, so there is reachability, but you'll notice that show iBGP sum, you'll see that the state is still idle. It's not connecting at all. So why is that? We have reachability here. We're trying to peer through a loopback. We can ping 6.6.6.6 from the 4, and from the 6 we can ping 4.4.4.4. By eyeballing our configurations, it looks like all the same configurations, update source, passwords, everything like that on the 6s. So what's wrong here? Well, here's the thing, right? eBGP has a default time to live, a TTL value of 1. Now that is because it is assumed that between autonomous system numbers there is going to be no IGP running. The only protocol running will be BGP. So how can you establish neighbor adjacencies if you can't have reachability with the loopbacks. So think about that, what I mean here. If between here there is no IGP running, the assumption is it's only BGP, how can these two loopbacks meet each other? You'd have to configure a static route or an IGP, but that is assumed that that's not happening. So the TTL is 1 because it assumes that you're going to have to connect on directly connected interfaces. That's the only way you can connect without configuring static routes or IGPs if they're directly connected. So eBGP usually, well by default, it wants you to connect on directly connected interfaces. So the TTL is only 1. If you want to configure on a loopback, you can configure static routing here or even configure an IGP if you want, but you have to change the TTL so that it's not 1 hop away, because what we're doing here is saying the neighbor should be 1 hop here, and a loopback, even though you think, okay, they're the same, the router's directly connected, the loopbacks are directly connected, they're not though. The loopback is another hop away. It's actually, from here to here, it's really going here and then a second hop for the loopback. So what you need to do is type in this command and change the actual time to live value on eBGP, so just remember that. So if we do router BGP 13 and do neighbor 6.6.6 and we do eBGP multihop, and now you can specify the amount of hops. Now if you just do eBGP multihop, it will go to the default of 255. It's not a good idea just to leave it at the default. You only need 2 hops, so specify it's going to be 2 hops, and that will get you to from here to this one, and then 1 hop into its loopback, and just do the same thing here. So if we do a router BGP 79 and do neighbor all the 4s and do eBGP multihop 2. Give that a little second. And now you see we now have our BGP adjacencies come up. And the state is no longer idle. So what we're going to do now is let's test that out and see what our reachability is. So we'll actually do we'll add another loopback in, so just do 85 whatever IP address, 85, 85, 85, and we'll do router BGP and we'll advertise into BGP. So network 85, 85, 85, 85, mask, okay, and do a clear IP BGP. Okay, so now we're receiving that route here, and let's see if we can get it here. We've got it there, and let's have a look here. Try IP route, you can see it here. Now you'll notice actually on here, we won't actually see the route here, and that's for a reason, because of iBGP. It's not there, but if we do show IPBGP, you can see the prefixes that actually been advertised. If you want that to appear, I'll just quickly just make it appear actually. Don't worry too much about what I'm doing here, I'm just going to just pop this in. This will all be explained in my iBGP series, so go match int. I'm going to do router BGP 5. Show IP route, and now we have all the 85s, and if I just go into router BGP 5 and just advertise our network so we can get return traffic. And if we do a ping 85, 85, 85, 85, we now have full reachability between all of the devices here. So that is pretty much how to do BGP peering with passwords, peering via loopbacks, peering over an IGP, and using static routes and multi-hop. What I will say actually, just this is an actual wee idea, see if you want to take out a neighbour, like say for example, you want to shut down a neighbour for whatever reason, we do a do show run stop section BGP. You'll notice we've got all these configurations like description, password, timer, so on and so forth. See if we happen to go and do, let's just try to shut down the neighbour. So we'll do router BGP 24, 24 that should be, sorry, and do no neighbour 24001 just to shut it down. Remote AS13. What you'll notice is show run section BGP. By doing so, we've actually taken away all the configurations of descriptions, password, timers, everything. So you can imagine if you've got lots of configurations and you want to shut down a neighbour, just by typing that in, you actually lose everything. A better way to do it would be, so in this case, show run section BGP. As if we did router BGP 79 and did neighbour 4.4.4, just do shutdown. That will allow you to take down the neighbour, but you'll realise that do show run section BGP, you've not lost all your configurations between the four. If you want to bring it back up, just effectively do no neighbour 4.4.4.4 shutdown, and it'll bring it back up, and you see that we still have all of our configurations. So that's just a little bit of a trick to remember in case you need to bring down adjacencies temporarily. Don't type in no neighbour and then the AS, you're going to lose all your subsequent configurations on it. Just do neighbour and the neighbour ID or neighbour IP address and type in shutdown, and then do the reverse of just do no neighbour IP address shutdown, and that'll bring it back up. So I think that'll be the end of the video. Like I said, there was nothing too much to this video. I just wanted to do a quick demonstration on the different scenarios when you're peering between iBGP and eBGP and loopbacks and authentication and timers and so on and so forth. So I thought I'd get this video out. The next one, I'm not sure which it will be on. Maybe do possibly iBGP and route reflectors and stuff like that. But yeah, I'll get to that soon. So thanks very much for watching, and I'll see you guys soon. Bye bye.